Welcome to lesson 2.6 on solving exponential problems using logarithms. We're going to have a little bit of deja vu here in this lesson because we've actually already worked with some exponential problems. But when we had to solve for the exponent, we were just using guess or check or Desmos to figure out what that exponent is. Now we can use our rules with logarithms to figure out what the answers are without having to use that guess and check. So if you had trouble with those word problems before, this gives you a second crack at it. Hopefully you get better at it as time goes on here. All right, example one, $1,000 invested. It should be is invested. I see I have a typo here, so you can fix that on your copy. Is invested at a rate of 4% per annum. So remember that per annum means per year. So that's per year. That's what the A means, per annum or per year. How long will it take the investment to double if it's compounded annually? So annually means one time per year. And that, therefore, means that our initial value is this $1,000. Initial value is $1,000. Our rate for our compounding period, our rate of interest per compounding period, we take that annual rate of 0.04, and because it's only one time per year, we're dividing it by 1. I mean, that's kind of useless. It really is just 0.04. But when we get into the ones that are semi-annually, we would be dividing by 2, or quarterly, we want to divide by 4, or monthly, we divide by 12. Now, when we set up our equation here, overall, the amount at the end is equal to your initial value, which is your principal, and then we have our base, which is 1 plus our interest rate per compounding period, and then the exponent is the number of compounding periods in total, not just per year, but in total. So if it's compounding one time per year, the n is actually the number of years. So in this case, when we fill our information here, the amount we're going to have is $1,000 to begin with. We're going to have 1 plus 0.04, which turns into 1.04. And then the question is, how long is it going to take to double? So we want to know how many years, and it's just our number of years, and we want it to double. So our A value over here has to be 2,000 because 1,000 doubled is 2,000. So my first step in solving this, now that I've got everything in its place, would be to divide both sides by 1,000 to try and isolate that, the base, the power, the base with the exponent. So what that results then in is 2 equaling 1.04 to the exponent of n. Now at this point we would take the common log of both sides. So we're going to get the log of 2. The log of 2 is equal to the log of 1.04 to the exponent of n, and then we can apply that power law of logs to make that n times the log of 1.04, and that's still equal to the log of 2, logarithm of 2. This is all base 10, so it's easy to calculate on our calculators. And then to get n by itself, it's being multiplied by 1.04, and I just grabbed the wrong tool there. Let me try that again. We're going to divide by the log of 1.04 to undo it here, and that means we're dividing this by the log of 1.04. And then you put that in your calculator, and you're going to get a value for the number of years. And our number of years, I think I got 17.67 for that. Hopefully I did that correctly, but 17.67 is our number of years. Or we could say 17 years, and then to get the number of months, you just take your 0.67, times it by, multiply it by 12, and that will give you your number of months. So it's about 17 years and 8 months, approximately. Okay, so hopefully that makes sense with that question. Make sure that if there's anything you're not understanding, put a little note beside it. If you're doing this at home or if you're in class, make sure you're asking for some extra help with that, because that's why I'm here. I can clarify things for you. Okay, let's see where we're at now. Let's take a look at the next one. I'm just going to try and draw line down here to separate these questions just so that we can have a visual separation and we don't get confused. Now our interest here is compounding semi-annually. So when I calculate my I, this time we've got 0.04 divided by 2, which gives us 0.04. 0.02. So I'm just working across this time because I'm going to run out of room potentially here. My a value, this time because I'm compounding semi-annually, I'm going to have 1 plus I to the exponent of, actually I'm going to put this, I'm going to erase that and actually start putting my values directly in here because we've already gone through the explanation of what everything is. We want our investment to double, so my a value has to be my 2,000. Our principal started at 1,000. My base will be 1.02, 1 plus the I value, and it's compounding 2 times per every year. So my n is representing my number of years. 2 times the number of years would give me how many times it's compounding altogether. All right, process is the same, common log both sides. When I did that, I got about 17 years and 6 months. I got about a 17.5 as my final answer. Try that question on your own and see how you do. And move on to the quarterly one. Try that out, see how you do on that. But put this video on pause while you try it, and then you can check your answers after. Okay, and in completing those answers, I got that semi-annually worked out to be about 17 and a half years, whereas quarterly works out to be about 17 years and 5 months. So you can see the more frequently it compounds in the span of a year, the faster your money will grow. And while a month or two doesn't seem like it's a whole lot of difference, I mean 8 months versus 5 months for annually versus quarterly, if we look at saving for retirement, we're looking at saving for 40 years perhaps if we start right at the beginning of our careers, or 30 years depending on when you actually start making those payments. So it can have a significant impact. Plus we only have $1,000. If we're working with a larger sum of money, and as you save for retirement and get more and more money put into that retirement savings, it's going to make a bigger impact. All right, so that's if the interest rate was the same, but you're just compounding more frequently. All right, let's look at the next. In 1995, Canada's population was 29.6 million and was growing at a rate of 1.24% per year. Estimate the doubling time for Canada's population growth. So we're asking how long will it take to double? That's what the doubling time means, the time it takes to actually double. So very similar to our previous question, only we're starting with an initial value of 29.6 million, and then we want it to double, so we double that number, and we're growing at this rate every year. So that's a fairly straightforward question. Give that a try, see what happens there if you can manage through it. Once you get that doubling time, we're going to re-express Canada's population function with a base of 2. So we're just going to express it a different way. This one, initially your base would probably be a 1 plus 0.124. And then we're going to change it for part B to have a base of 2. All right, when I've solved this, I doubled my population to get 59.2 million. Divide both sides by the 29.6 and I get my 2. So that's an indication there that I've done that right, because if I'm looking for things that are doubling, once I divide my initial value by my final value, that should equal 2, just based on how we set that up. I solved and I got about 56.24 years, or 56 years and 3 months. Remember, 0.24 times 12 is how I came up with the 3 months. That's approximately 3 to get the 3 months. All right, now to express Canada's population as a function with a base of 2, everything is going to stay the same. Population P equals, your initial value stays at 29.6. and then it changes after this. So that part stays the same. We're going to change the base to be a 2, so we're looking at doubling. Now we know it takes about 56.24 years to double, so our exponent is a fraction with the 56.24 on the bottom and the n here, where n is the number of years. Okay, so our population, P, and then we're letting n be the number of years, where P is the population in millions, is the population in millions, and the n would be the number of years. Okay, so if it was 56.24 years, you're going to have 56.24 divided by 56.24, which makes that exponent a 1. So then you're just taking your 29.6 and timesing it by 2 to the exponent 1, or just 2. Okay? All right, I'm going to do the next 2 examples on the next video. All right, there we are.